Hello everybody, my name is Mike Guy, and in this video we're going to look at finite state machine artificial intelligence in Allegro 5. Now before I start, I just want to kind of give a brief overview of finite state machine artificial intelligence. Basically, finite state machine artificial intelligence is one of the industry standards for video games as far as artificial intelligence goes, because it's pretty easy to implement, it's pretty efficient, there's not a whole lot that goes on. Basically, what we're going to do is we're going to simulate intelligence using basically finite states, predefined rigid state systems that, when enacted in such a way, gives the illusion of intelligence. Okay, so we're not going real deep into artificial intelligence here, but this system works great for video games because it's simple, it's fast, it's efficient, and it gives us just enough of a strategy on the enemy's part to make games more challenging. The code I'm using is basically my shell code. A couple things are different than just my shell code. Some things from the previous video. I have IOStream here. I have my escape key here. That's different. I'm not really going to use that all that much. I have my change state function. However, you will notice my change state function is empty. I also am initializing my state variable to -1, and that's about it. Everything else is pretty much just shell code. So if you're using the code from the previous video, you're going to have to delete what we had in render and in the change state function and in the update section and stuff like that, and our call to change state, because I got rid of all those. Also, the state that we had, I removed that as well, because we're going to kind of be doing a different type of state here. One last thing, actually, now that I think about it, I'm going to go ahead and remove escape from here again. We're going to go back to the way the shell code had it, where we're just, if they hit the escape key, we're just going to do done equals true. If they hit the escape key, we're going to do done equals true. Just double safe there. Okay, true or more true. Okay. So now we're ready to begin. What I'm going to do, basically, to tell you what we're going to do before we do it, is we are going to make a player and an enemy. Now, the enemy is going to chase the player only if the player gets within a certain distance, a threshold. We'll call it an aggro range. If the player gets within an aggro range, the enemy is going to chase the player. Now, if the player moves outside of the aggro range, obviously the enemy is going to stop chasing the player. It's going to go back to its starting point. Or, if the player basically makes the enemy chase it so far that it would pass through a certain distance from its starting area, it'll instead not go that far. So basically, it's like, think of it like a dog on a leash, can only go so far from its starting point. And so basically the enemy will chase us only so far, and the enemy will chase us only if we get so close. Alright? So to do all this, we're going to need the math library. So I'm going to do pound include, and I'm going to do math.h, like that. Okay. We're going to need the math library to use some of our math functionality. Alright. Now, knowing that we're not necessarily doing game states in this video, we're doing finite state machine artificial intelligence, our states are going to be different. Our states now, and it's still going to be state, are going to be idle, our enemy is waiting, alright, chasing, or retreating. Okay. Now, normally, the state machine for artificial intelligence would be a composite class inside of an enemy class, and that whole thing would be encapsulated away. Since we're not using all that stuff, we're going to do it here, very basic, if you will. Okay. But otherwise, this stuff is going to remain the same. I am going to need a couple helper functions. My helper functions are going to be float, check distance, and that's going to be in existence basically to tell us how far objects are from each other. Alright, and check distance is going to take int x1, int y1, int x2, int y2. So that function is going to exist to tell us how far objects are from each other using the Pythagorean theorem. And then we are going to have angle to target, and that is going to tell us the angle that exists between two components assuming a horizontal flat plane. And we'll look at that a little bit more closely when we get there. And that's going to be int x1, x1, int y1, int x2, int y2. Alright. And those will be our helper functions there. Alright, so as far as variables go, we have our state, which is awesome. And we're going to need to have a player x and y, so we're going to do int player x, and that's going to equal 0. Int player y is going to equal 0. And then we're going to have what I'm going to call a cave. And the cave is basically going to be just the starting point for our bad guy. So I'm going to do constant int, because I don't want my cave changing. It's going to be cave x. That's going to equal our width minus 100. And my constant int cave y is going to equal height divided by 2. Okay, that's going to be my cave. Now my bad guy is going to start at the cave. So I'm going to do int bad x equals cave x. And int bad y equals cave y. Just like that. Awesome. And I need to specify a threshold. So I'm going to do int threshold equals 175. 175 is arbitrary. I just through testing picked that because I liked how it worked. So basically, if the player gets within the threshold of the enemy will chase it. Also, if the enemy gets beyond the threshold of the cave, the enemy will stop chasing. Okay? Awesome. Alright, so we got all that set up here. Let's go ahead and work through our helper functions and then get into the update, because the update's where a bunch of the meat is going to take place. So for my change state function here, I'm going to come down here and we're going to do basically kind of like what we saw before. I'm going to do if state equals idle, else if state equals chasing. These are going to be our pre-commands, our pre-processes. Else if state equals retreating. And I'll go ahead and copy this there. I'm going to do state equals new states. I'll paste it there. Also my render, I'm going to paste it. Just that, and I'll come back to it in a second. And in my update, I'll paste it, and I'll come back to it in a second. Okay. That way I just don't have to type it out all those times. Alright, and so what we're going to say is if we leave the idling state, std cout colon, I'm going to say leaving the idle state, and I'm actually just going to copy this whole line here. Just like that. We'll say leaving the chasing state, leaving the retreating state. Awesome. Alright. Now for the post process, I'm going to say, we'll flavor this a little bit. We'll say like now idling, something like that. Just copy that. And we'll say now chasing the player. And finally for retreating, we'll say now, and we'll say now retreating back to my cave. Okay, just a little bit of flavor there. Awesome. So our change state's working out for us. We don't really need to do too much to the pre-processing and post-processing of our enemy's AI state. But this is basically the AI state of the enemy. This enemy can have three mindsets. It's either waiting, it's chasing, or it's retreating. And we can use these three states. I know this doesn't seem like it's doing a lot, but that's actually it's pretty important. So now let me go ahead and grab the headers here to my check distance and angle to target. And I'll paste them down here. Okay. So we've seen both of these functions actually before. Check distance I used in distance-based collision detection. Angle to target I used in my gravity demo. So I'm not going to do too much explanation here. We're just going to kind of flow through it. If you want more of an explanation, you can go back to those videos. But this is just the Pythagorean theorem, so I'm going to return the square root of pow, which is our math function. Now, since we're doing integers here, you're going to get normally an ambiguous, you're going to get an error with the compiler, with the IDE, that you just get an ambiguous call to the POW function. So what we need to do is we need to cast it to let it know we're doing floats. We want float level precision in this. So I'm going to do float, then I'm going to do x1 minus x2, raise it to the second power, and that's going to be plus POW, and once again, float y1 minus y2 to the second power. Right. That's it. That's that whole function. Okay. We're just checking the distance there and doing that little bit of math. Awesome. Now to get our angles, we are going to do float delta x, and that's going to equal x2 minus x1, like that, and then float delta y, which is the change in x and change in y. Alright, so that's just the difference between the two. Y2, oops, minus y1, awesome. And then we are going to return the arc tangent, so a tan 2 of delta y and delta x. Okay. Oh, that's should be that. There we go. The arc tangent, a tan 2. Okay. So if you don't know what the arc tangent is, just go ahead and look that up. It's a little bit of a trick for you. Awesome. Okay. So those are our helper functions. So let's get to our updates. Alright, so now we have the framework for our states. Our enemy can change his states, we can check our distance, we can check angles. Alright, that's going to make these functions here are going to be very necessary to making this much better than we could normally. I thought about originally doing this where we just did, like, you know, checking a horizontal plane, you know, and I'm going to chase you just on the x-axis and stuff, and that's kind of boring. So we're going to use this to actually make it much cooler. Alright, so let's come back up here to our update section. And this is where we're going to do a lot of our code. So let's think through this here. So if I'm a monster, right? I'd like to think that I'm not, but if I'm a monster and I'm idling, okay, the only thing that's going to snap me out of my idling stage is seeing an enemy. Or I guess, hey, how about this? Instead, I'm a dog, you know, just chilling in the yard, and you know, I'm just going to continue chilling in the yard until I see, like, the postman or something, and I'm going to chase the postman when he gets closer. Alright? So what we need to do is we need to check every time we're during the idle state, you know, is the enemy close to us? And if so, let's do something about it. Alright? So I'm going to say if threshold, remember the threshold is how close they have to get. So if the threshold is greater than, okay, is going to be greater than the distance. So if the distance between me and the player, between the enemy and the player, is smaller than my threshold, I'm going to start chasing him. I'm going to do check distance, and I'm going to pass in player X and player Y, and then bad X and bad Y. Okay. So if that's the case, then I'm just going to change state, and I'm going to pass in state and chasing. Note how I don't actually chase or anything here. Right? I'm simply changing the state. If he gets close enough, I switch my state. That's the power of finite state machine AI. Right? I'm just switching my state. And then in that state, I figure out what I'm going to do. Okay? So real simple. Alright? Now, let's look at our state chasing. Now, let's think about it. Once again, you know, if you're a dog and you're chasing the postman, okay? You're either going to continue chasing the postman until either he gets far enough away that you stop chasing him, or you know, you hit the end of your leash and it stops you. Okay, and so we're going to simulate that. So we're going to say if threshold is less than check distance, we're going to pass in bad X, bad Y, cave X, cave Y. So if we are further away from our cave X or cave Y, our origin, if we're further away than the threshold, we need to reel it back in here because we've gotten too far. So if that happens, we're going to change state, and then we're going to do state is going to be retreating. Awesome. Else, okay, so if we haven't gotten too far, wait, why is that? Oh, needed an extra. There we go. Awesome. Okay, I was shy. Parenthesis. Okay, so if that's not the case, if we haven't gone too far yet, let's go ahead and chase. So I'm going to say float angle. This is going to be the angle between me and the enemy and the player. Okay, float angle is going to equal angle to target, and I'm going to pass in bad X and bad Y and player X and player Y. Okay, that's going to be my angle. I'm simply going to do bad Y plus equal, and we need to give this enemy, this dog, a speed. Okay, I picked 2, completely arbitrary. I picked 2 because it made it slow enough that we could sort of play around with it. Any higher than 2, and it was a bit faster, which made it more challenging to duck around. But this isn't about being challenging. This is about a demo. So I'm going to do 2. Okay. So what's going to happen is basically we're going to be some fraction of 2 based on the angle. So I will either be my range will be from 0 to 2. Okay. I'm either moving 0 pixels on the y-axis if we're completely horizontally equal, or I'll be moving 2 pixels on the y-axis if we're completely one on top of the other. So anyway, times sine of the angle. It's a little bit of trick for you. This, by the way, super useful. Okay, angular velocity or movement or angled movement on a 2D plane or whatever you want to call it, whatever algorithm you want to call this. Like, I'm actually honest. I bought a black T-shirt, got a white marker, and put this calculation on it. I have a T-shirt with these 2 functions on them, so I never forget them. So yeah, that's not an exaggeration. I actually have a T-shirt that says that. So super useful, just great stuff. Now, okay, so this basically is going to move our enemy towards our player, and then once we move towards our player, we're going to say, hey, has the player made it beyond our grasp at this point? And if so, okay, the player's made it away, we're going to start retreating. All right, so I'm going to say if threshold is less than check distance, and once again, bad X, bad Y, player X, player Y. Okay, oop. Yep. So if they've made it away, we're going to do change state, pass in state, and retreating. The reason we didn't include this if statement with this statement up here is because we want to give ourselves a chance to catch up to the player before we say, okay, alright, he's made it away. Okay, that makes it just a little bit more challenging. Alright, so that's the entirety of my chasing update. Basically, hey, have we gone too far? No, well, let's chase. Now, is the enemy too far? No, okay, we're good. Or yes, okay, we're going to change state. Alright, so now let's think about retreating. Alright, so retreating. Okay, so if the dog is retreating, alright, one of 2 things is going to happen. He's going to keep walking back to his cave, his starting point, until he's there. Or the enemy's going to get close enough again, he's going to start chasing him. Okay? So we can do something really simple here. So first off, I'm going to say if 5, and just follow me here, is greater than or equal to check distance, and we'll pass in bad X, and bad Y, and cave X, cave Y. Now, the reason I'm doing this is because as the enemy gets closer and closer and closer to the origin, I don't want him to go past the origin and sort of like circle around it and stuff like that, because he's never landing directly on it. So I'm saying, hey, if he gets close enough to the origin, if he gets within 5 pixels of the origin, he's practically there. We're just going to put him on the origin. Alright? That way he's not bouncing around, never quite exactly on the origin. So if that's the case, I'm going to do bad X equals cave X, bad Y equals cave Y. Okay? And then I'm going to change state, and now I'm going to be idling. Alright? Because, hey, I'm back at the cave there. Oh, it's not idling. I'm sorry. It's just idle. Yep. The other one's chasing and retreating. I really should have made that one idling. I didn't. So I need to say else, right? Because if we're not close enough to the cave, then we need to move ourselves toward the cave. And we're going to do something that's going to look very similar to this right here. So let's grab it. Let's paste it. And instead of doing player X, we're going to do cave X. Player Y is going to become cave Y. And then, once again, we're just going to move ourselves along that line. And you're going to see this is going to make it look pretty darn cool. So just wait till we do this. Now, as we've moved closer to our cave, we're going to say, hey, at this point, is the player back in our field of view? So I'm going to say if threshold is greater than check distance, and I'm going to pass in bad X, bad Y, player X, player Y. If they are, change the state and chasing. Awesome. And that's it. That is our updates for our final finite state machine artificial intelligence. This enemy is going to chase the crap out of us until we get out of range, and it's going to stop chasing us, and it's going to look really, really cool. So let's get something graphical, because right now we can run this and it's actually going to work, but we can't see anything. So let's make it so we can see something here. All right. So I lied to you. I actually don't need this at all, because we're not doing any menus or anything. So I'm just going to render everything every cycle. I'm not going to render only special things based on the state. So sorry about that. Anyway, what I want to do is I want to, first off, I want to have my objects, my player and my bad guy, and my player and my bad guy are going to be just squares. But I also want to draw circles that are going to represent the threshold range, so I know when I'm getting to my threshold range, right? So I'm going to draw these first because I want them to be behind everything else. I'm going to do AL, draw, circle, and I'm going to pass in cave X, cave Y, and threshold is my radius. So it's going to be AL, map, RGB, actually RGB A underscore F. I'm going to do floats here, and I'm going to do the F or the A so we can do alpha channels. And I'm going to do 0.5, comma 0.5, comma 0.5, comma 0.5. So it's going to be white and slightly transparent, or half transparent, and just 1 for my thickness. Awesome. Oh, I see that I missed a comma. Whoops, there we go. Okay. Now I'll go ahead and pop that down again, but this time we're going to do the bad guy X and bad guy Y. Since they have the same threshold, we're going to have the same thing here, but so we can differentiate the circles. I'm going to make this one hideous magenta, half-wave transparent, instead of white. Okay, so that's my threshold. Okay, and so let's just draw the players now, or the player and the enemies. We'll do AL, draw, build, rectangle, and I'm going to pass in, first I'm going to do player X minus 10, player Y minus 10, and player X plus 10, and player Y plus 10, and my color is going to be AL map RGB, and I'm going to do hideous magenta. Actually, you know what? I lied. I'm going to do white. I'll leave hideous magenta to be my enemy because that's the color of his aggro circle. So there we go. And I can just kind of copy this here, paste it again, and this time I'll do bad X, bad Y, bad X, bad Y, and hideous magenta. Okay, so we have our enemies. Okay, we have our player, we have our enemy, we have our cave threshold being drawn, we have our enemy aggro range being drawn. Our updates are working. Everything's going to be fantastic. One last thing, and hopefully you've noticed this, you've seen this. How are we moving the player? Right? I don't want to use the keys to move the player. That's not going to provide us the level of finesse that I want. So I'm actually going to go ahead and install the mouse system for this. And we're going to move the player using the mouse system. All right. So we're going to need to modify our shell code a little bit. I'm going to come up here under my project init, and I'm going to do al install mouse. Okay. Now that I've installed the mouse, what I'm going to do is I'm going to come down here, and I'm going to register my mouse as an event source. Just like that. Al register event source. I just copied this from other codes, so I don't have to type it out. Al register event source, passing the event queue. Al get mouse event source. Okay. And then in my if statements here for my different events, I'm going to, right above my game update, I'm going to say else if, and I'm going to say ev.type double equals Allegro event mouse axes, whatever. And I'm just simply going to say player x equals ev.mouse.x and player y equals ev.mouse.y, just like that. Okay, so now everything's working great. Let's go ahead and build this. Hopefully I didn't make any mistakes here. Oh, hey, succeeded. Fantastic. Okay, so now that I'm thinking about it, actually, one last thing we got to do. Our state is currently -1. So state is not actually any real state yet. Obviously, we're never going to run any of this code because our state isn't idle or chasing or retreating. We need to call our initial change state. All right. So my initial change state is going to happen. It can happen really anywhere up here, but I'm going to do change state, and it's going to be state, and I'm going to set my enemy, initialize him to be idle. Okay. So now he's going to be idle. So we're going to run this, and I've got my console window. I can see now idling. My enemy's idling. I can see that my mouse is controlling my player. Now I can't mouse over it to show you here, but you see my hideous magenta enemy? I see his aggro range. You can see I can dance outside of his aggro range all day long. Alright? The second I go into it though, oh, he's chasing me. And if you look over at my console, you can see leaving the idle state, now chasing the player. Okay, he's chasing me around. Furthermore, you can see the white circle. That's the limit. That's how much he'll chase me. He won't go beyond that white circle. We'll test it. Oh, there we go. You can see if he hits that white circle, you see my console's going crazy because it's bouncing back and forth between chasing and retreating. That's because this was real simple. We didn't really write the smoothest of code to prevent that, and that's fine. The player will never see that. Anyway, he's just bouncing back and forth trying to get to me, but he can't. He cannot go beyond that threshold. And you'll see if I leave his aggro range, he just he goes to the retreating state, leaving the retreating state, now idle. Okay? So I leave his, and there he goes, back to home. And back to home. Alright? So he won't chase me so far, and if I leave his aggro range, he goes back. Okay? So we've basically simulated some form of primitive intelligence with this enemy. Alright? He's chasing us around. He's chasing us around. But no matter what, if we leave his aggro range, he goes back to normal. This is cool too. If I stay within his threshold, or within the cave's threshold, but outside of his aggro range, when he comes into my aggro range, he's going to start chasing me. Watch. I'm going to bring him up here. Okay? I'm going to leave his range, but I'm still in here. Now watch. Oh, hey, there he is. Now I'm going to chase him down here. I'm going to retreat. Oh, there he is. Now I'm going to retreat. And then, oh, there he is. And now he's chasing me again. Right? So, obviously nothing happens when he gets there. Just fast a little bit. But you can see we have finite state machine, artificial intelligence, and a primitive enemy here. He's just going to chase us around. You can use this code to do all sorts of stuff, especially the angle to target and the check distance for heat-seeking missiles and whatever, missiles that seek the player or missiles that seek enemies and things like that. Anyway, this video is going a little bit longer than I wanted it to go, so I'm going to start ending it right here. But that's going to kind of conclude my primer on states. Like I said, there's a whole lot that can be done and said about it. There's a whole lot of code we could do, classes, object-oriented programming, finite state machine systems, and whatnot. But this is the concept of it, right? We just have a series of states that flow into each other, right? We go from idle to chasing to retreating to chasing to idle to retreating to idle, whatever. They all flow into each other, and it gives the illusion that our enemy is smart. Our enemy knows when to chase us, it knows when not to chase us, It'll come right at us, right? We have the angle code, so it's coming right for us, So it's a fairly smart, enemy, to the player anyway. We know better. We know it's just a bunch of if statements and integers for state. It's not really anything all that special, but the enemy doesn't know, or not the enemy, the player doesn't know that. So we can get away with a lot of cool stuff. All right. So that concludes the part of the series where I talk about states. And go ahead and play around with this. Try to get it incorporated in your own game because it's pretty cool. All right, thanks.